Somebody tell me what we're talking about today. So we're solving a system of linear equations. So everybody knows what that is, right? Oh, no? Okay, let me think about this. Do you know what a digestive system is? What is it? So it's just one thing? Multiple things serving the same purpose. Okay, what about a circulatory system? What does that do? Circulates your blood, right? Okay. What about your skeletal system? Your bones and stuff? What about that other system? Oh, respiratory. Thank you. Respiratory system. Breathing, right? So what is a system? A bunch of things combined to work together for one cause, right? Okay, so if we're talking about a system of linear equations, what would that be? A bunch of whats? A bunch of equations. Okay, a bunch of equations doing what? Working together to get the answer. Okay, does that make sense? So if we're working with a system of equations, how many equations are we going to have? Well, you don't know because the word's plural. That just means we're more than one, right? Okay. So today, if we're working with a system of linear equations, how many variables are we going to have? 2, right? X and Y. If we write the equation of a line, if it's in slope-intercept form, it's y equals mx plus b, right? 2 variables, x and y. So if we have 2 variables, how many equations do we need? At least 2. What about if we had 3 variables? How many equations would we need? At least 3. What if we had 12 variables? At least 12, right? Okay, so for the record, we're not going to do 12. Just so you know, okay? All right? Not 13. We'll do 2, 3, and maybe 4. Okay? Today we're going to do 2. Today we're going to do 2 equations with 2 variables. That's linear, right? So, let's see. Keith, can you help me out? Thank you. We're going to start by looking at problem number 1. If we're going to solve systems by graphing, like problem number 1, what do you think we ought to do first? Well, we probably ought to graph it, right? Because it says solve it by graphing, so we need to graph it. Now, okay, I have more. Thank you. One apology before we begin. Some of you are already freaked out by the fact that the holes are on the wrong side. I had someone helping me punch holes in these, and we didn't realize till she was all the way done that the holes were on the wrong side. So if that bothers you, I need you to get over it. Okay, thanks. Sorry about that, okay? All right. I know that you and your calculator are so close friends, and you don't like to do graphing without it because you feel like you're cheating, okay? Today we need to cheat a little. Okay, we need to graph this without our calculator. We need to remember how to graph these without a calculator. It's going to be true all year. All year it's going to be true. I want to be able to say, let's do this thing. And as long as we understand the concept, then I'll show you how to do it on the calculator. Okay? If you already know how to do it on the calculator, you just be quiet. Okay? We'll get there. But I need to make sure you understand the concept first. Okay? How do you graph this first equation? So I start with the y-intercept. So I go up 4 and put a dot. And then what? Why would you go down 3 and over 1? That's the slope, right? So down 3, 1, 2, 3. And which direction over? Right here? Oh, right? Well, that'll eventually give me a negative slope, right? Is that what I need? Yes, so that's how I know for sure. 1, 2, 3, right 1. 1, 2, 3, right 1. Now, how many points does it take to make a line? 2. Then why did I draw 4? Well, isn't it easier to see now? Isn't it easier? Isn't the line easier to see now? How do we graph the second line? So go down 2 on the y-axis. Rise 3, run 1. Rise 3, run 1. From this point, could I fall 3? As long as I run backwards 1? Okay. So did I solve the system by graphing it? Well, I did if I know what I'm doing, right? Where is my solution? Where they cross. So if I just leave it like this and know where my solution is, I will not get full credit on this question. How will I get full credit? By writing it down. What am I going to write down, Barry? Why would I write down 1, 1? That's where they cross. So when I'm solving any system of equations by any method, how should I write the answer? What's that called? It's a point, right? Because you know by graphing it, solving by graphing, the solution is where they cross. Well, they're going to cross at a point. So I need to write my answer that way. The only way that's not true is if I'm working with a word problem. And then a point's not going to make sense. A sentence will make sense in a word problem, right? Okay? And how do we write our sentences? Capital letter, all the correct punctuation, all the correct spelling, and grammar. So like an actual sentence, right? Okay. How comfortable with solving by graphing are you? So I kind of did the easy one for you. Although 3 and 4 aren't necessarily hard, but I want you to look at the problems real quick for 3 and 4. How are they different? Oh yeah, they're not solved in slope-intercept form, are they? So do you see why I went ahead and did this one for you instead of 3 and 4? Because you should really know how to put it in slope-intercept form, right? Do I need to go through that with you? Just one? Okay, I'll do one. I'll do the first one on problem 3. How do I get that one in slope-intercept form? I need the y by itself, so what do? Oh, you can, can't you? Aren't there at least 2 different ways to do this part right here? So he's saying add y to both sides. If I add y to both sides, I'm going to end up with x equals 3 plus y. And then I'd subtract y from both sides, right? To get y equals x minus 3. What would happen if I subtracted y from both sides? Excuse me, if I subtracted x from both sides? I'd get negative y equals negative x plus 3. Except then I'd divide everything by negative 1 and I'd get y equals x minus 3, wouldn't I? Okay, so it's either way more correct. No. You okay with that? Do I need to do some more or are you good? Okay, so you'll have to do that for each one of these lines when you do 3 and 4 here in just a little while for homework, either in class or for homework tonight. Just get them in slope-intercept form first. Okay? Let's look at number 5. What are the directions for number 5? Substitution. What happens if I get sick? I have a sub, right? I have somebody who comes in here. What do? Do they sit here and stare at you? So like what I would do if I was here, right? Okay. So a substitute is the same kind of thing, but just a different kind of thing, right? So it's exactly the same, but totally different, right? That was just a little joke. Okay. Substitution is where we take something that we know and plugging it in for something else that's also the same thing, right? Do you remember doing substitution? You've done all these. You did all these in Algebra 1. This is just a reminder day. Okay? So I need to work a little bit harder to remind you. Is that what you're telling me? All right. So let's talk about substitution then. You know that I don't write very small, and there's not enough room on that worksheet for me to do number 5. So I'm going to do number 5 over here on some scratch paper for you. Okay with that? Y equals 4x minus 9. Y equals x minus 3. When I solve by substitution, I need to isolate at least one variable. Mostly I just isolate one variable. The cool thing about number 5 is that I already have 2 variables that are isolated, don't I? I already have 2 variables that are by themselves. So I need to take what I know for y in the second equation and just substitute it into the first equation for y. So what I end up with is x minus 3 equals 4x minus 9. Does everyone see where that came from? Okay. How long have we been solving equations like this? 7th grade? 8th grade? Long time, right? So subtract x from both sides. Negative 3 equals 3x minus 9. Add 9 to both sides. 6 equals 3x. Because you divided both sides by 3, x equals 2. So am I done? Am I finished with this problem? Think back to how we're supposed to write the answer. Am I finished? What do I need? Why? What am I trying to find? I found x. What else do I need? I need y, don't I? Where should I go to find y? Oh, it doesn't, does it? I could choose either one of these equations and it's going to solve y for me, isn't it? So which one do you choose? X minus 3. Okay, so y equals x minus 3 and x is 2. Does anyone know what 2 minus 3 is? Negative 1? 2 minus 3 is negative 1? Okay. So now am I done? No? Why not? Oh, I had to make it a point. Okay. How do I write that? How'd you know it went in that order? Oh, okay. Sorry, that was a really silly question, wasn't it? Okay. But I ask it just in case, to make sure. Now am I done? Is this the answer? Are you positive?
Yes. No.
Is there a way you could be positive? Check it. Okay. Negative 1, because that's y, negative 1 equals 8 minus 9. Is that true? Okay. Negative 1 equals 2 minus 3. Am I positive now? Yes. Okay. I have to ask you a question to make you think for a second. Are you ready for that? I'm just warning you that you're going to have to think. Look back at this problem that we did just a second ago. Look up at the board real quick and look at this problem we did just a second ago. We graphed 2 lines and got 1 answer. Is that the only possibility? Is getting 1 answer? Are there any other possibilities besides just getting 1 answer? No? What else is possible then? Could I get no answers at all? Is there a way these lines wouldn't cross at all? Oh, if they're parallel. Okay, so that's another possibility, right? We could get either 1 answer or no answers. Is there any other possibilities? What is it? All of the answers? So if this line was here, and then this line was here, where would they be crossing? everywhere, right? So are there any other possibilities besides that? No, there's not, okay? We can either get one solution, no solutions if the lines are parallel, or infinitely many solutions. We'll learn to spell that later, don't worry about it, okay? Infinitely many would be if both lines are like one's right on top of the other, okay? I'm just giving you a heads up right now. All the problems that we're doing today, we're really focusing on finding the one answer where they cross. You're gonna find one answer on all the ones today. We won't always do that. Sometimes we'll have no solutions, sometimes infinitely many solutions, but today we're doing one solution. You okay with that? Okay, so there's number 5. Any questions on number 5 so far? Okay, let's go to how about number 6? I'll do number 6 for you as well. 4x plus 2y equals 10. And x minus y equals 13. Now this problem is already substantially different because there's not a variable solved for, is there? Well, then I have to solve for one. That's my job. Okay? So let's talk real quick through the problem and decide which variable we should solve for in this problem. Okay? I could solve for the the x beside the 4. I could solve for this x. If I solve for this x, I'd have to subtract 2y from both sides and then divide everything by 4. Would that be hard? No. Okay? But is it the easiest? Well, I don't know yet. Look at the y. If I'm solving for this y, I'd have to subtract 4x from both sides and divide everything by 2. Is that hard? No. But is it easier than solving for the x? Yes. Okay, because this is a smaller number, right? Okay. I could solve for this x. If I was solving for this x, I'd have to add y to both sides. Oh, that's real easy, isn't it? Is it easier than the y? Well, then it's easier than the x because the x was easier than the y, right? What about this y? If I solve for this y, what would I have to do? Subtract x from both sides and then divide by a -1. So is that easy? Yeah, but is it easier than the x? No, because on the x, all I have to do is add y, correct? So when you're looking for which variable to solve for, how are you going to decide? Well, you want the easiest one, don't you? Could I solve for any of the variables and get the correct answer? Yes. There's not a correct one to solve for. There might be an easier one to solve for. Or because there's 4 of them, easiest, right? So I could solve for any of them, but we decided we should solve for what? That one. That's probably going to be the easiest. Look for one that has the smallest coefficient. And if there's 2, like this one, they both have a 1 as a coefficient, but this one's negative, choose the positive one. Okay? So solve for this x. Tell me what to do. Add y to both sides. X equals 13 plus y. Now, we got to have a talk. Your whole life in algebra, they've said, get the variable by itself, the y, and then put the next variable first, and then the constant. And I pretty much did the opposite of that this whole time. First of all, I solved for x, and then I put the number first, and then the variable. This is okay. It really is. Okay? We're not trying to get it into a form. If I said put it in slope-intercept form, and I'm being really strict about it, I want it y equals mx plus b, right? We're not trying to get into a form here. I want a variable that's isolated. Did I isolate a variable? Yeah, then I don't care what order this is written in. If you need to put it y plus 13, because that's just how your soul is, just go for it. Okay? But if I write 13 plus y, know that that's also okay. All right? Now that I know what x is, what do I do with it? Which equation did I use to solve for x? First one or second one? Second one. Then I need to take what I know for x and take it back to the first one. Don't put it in the same one you solved it for. It's not going to help at all. Okay? I'm going to start rewriting the first equation, but instead of writing x, I'm going to write what I know x equals. Yes? What's next? We should distribute, right? We should distribute. So 4 times 13 and 4 times y, correct? What is 4 times 13? 52. Do you know that I do not know that in my head? I don't know 4 times 13 in my head, but I know that 4 times 10 is 40, and 4 times 3 is 12, and 40 and 12 is 52. You know you can do that, right? Break stuff up like that. We're going to be working on our numeracy this year, our comfortableness with numbers. Is comfortableness a word? It is now. Okay. What's 4 times y? 4y plus 2y equals 10. How comfortable would you be if I did 2 steps at one time? Want me to try it? Okay. If I subtract 52 from both sides and then go straight to 6y, do you see what I did? I combined my like terms and I moved that over at the same time. Are you okay with that? So 6y equals negative 42. To solve for y? Absolutely. Y equals negative 7. Now that I know y, what do I need? X. How do I find out x? Plug it in. Where should I plug it in? One of these two? Why couldn't I go here? Wouldn't that be better? Couldn't I go straight right here? Because I already have x solved for, don't I? I don't have to. If I can use this one because I got it from the beginning. Now I risk if I made an error here, but if I made an error here, I made an error over here too, didn't I? Okay, so I can go straight back to here where I already have x solved for. So x is going to equal 13 plus negative 7. What is 13 plus negative 7? Yep. What's my answer? 6 negative 7. Whoops. Are you positive? Well, let's be positive. 24 plus negative 14. So 24 minus 14 is 10. Correct? Okay. 6 minus a negative 7 is 13. 6 minus a negative 7. Am I positive? Yeah. Okay so far? Look on the back. What are the directions on the back? Elimination. Okay? What does that word imply? We're getting rid of something, right? We're eliminating something. We're going to want to eliminate a variable. Wouldn't the equation be a whole lot easier to solve if there was only one variable? A whole lot, right? Okay. So let's talk through problem number 15 and see if we can figure out how to do this. Or remember how to do it, because like I said, you've already done this in Algebra 1. I know it's been a while though, that's why I'm helping remind you today. So I have 8x minus 6y equals negative 20, and negative 16 plus 7y equals 30. If I want to eliminate a variable, I need to get that variable, whichever one I choose, same number, opposite sign. Are the x numbers the same number and opposite sign? Well, they're opposite sign, right? But one's an 8 and one's a 16. Are the y's the same number and opposite signs? Well, they're opposite signs, but one is 6 and one is 7. So I need to do something in order for them to become opposite signs. same numbers. Okay? Now, I notice that the x here is half of the y. The other x, isn't it? This x is half of this other x. So, am I allowed to multiply this top equation by 2 as long as I multiply the entire equation by 2? Am I allowed to do that? Yes, because I'm not changing the value of the equation, I'm just doubling everything. 16x minus 12y equals negative 40. Well, I'm just going to rewrite the whole second equation. Now do you see that the x values are the same number but opposite signs? Isn't that what I needed? Guys, sometimes on this particular worksheet it says solve the system by elimination. Sometimes the way that we're solving it is called solving it by combinations. Because what we're going to do now is combine these two equations. We're just going to add them together, combine them together. What is 16x minus 16x? Nothing. It's 0, right? What is negative 12y plus 7y? Negative 5y. What is negative 40 and 30? Is that an easy equation to solve? So easy. Because y equals 2, doesn't it? Well, if we know y, we need x. Where should we go to find x? Could we go here to these equations? We could, but well, that one's exactly the same as the beginning, so that's fine. But this one's twice as big as this one, so probably I want to go back to the beginning, don't I? Okay? Which one do you want to choose, top or bottom? Why would you choose the top? It's smaller. Yeah. Does it matter which one we choose? No. So if I choose the top, I'm going to say 8x minus 6 times 2 equals negative 20. So 8x minus 12 equals negative 20. If I need to add 12 to both sides to solve, I get 8x equals negative 8. Then to solve for x, what do I do? Yeah. Oops. X equals what? Negative 1. So what's my answer? Negative 1, 2. Am I confident about that? We could check, okay? Negative 8 minus 12 equals negative 20. Is that correct? Negative 8 minus 12 equals negative 20. Yes, that's correct, isn't it? Okay. 16 plus 14 equals 30. Yes. Am I confident? Yes. Yes. Thank you. Anybody have a question about this? Yes, ma'am. Right here? I took what I knew for y and substituted the y into the first equation. So I wrote 8x minus 6 times 2, because I knew that y was 2, equals negative 20. 6 times 2 is 12, so I have 8x minus 12 equals negative 20. Does that make sense? Okay. Any questions about this? So in this particular example, in order to get one of my variables to eliminate, I had to multiply one of the equations by a number, didn't I? Is that the only possibility that might happen? Let's look at 19. Negative 4y minus 11x equals 36. 20 equals negative 10x minus 10y. What's up? Oh, that's a good question. Well, this is just weird to begin with, isn't it? In the first equation, the y is first and then the x. But in this, look at the second equation. It's all messed up, isn't it? So how about if we decide like a common way to do this? Are you okay with that? Let's decide. Now, it's not the only way. I'm not saying it's the only way, but I'm saying if we're working together as a group, can we all try to at least start the same way? You okay with that? Then let's get each of these equations into standard form. All right? What do I mean by standard form? Remember standard form? AX plus BY equals C. So the X and then the Y and then the equal sign and then the constant. How do we do that for the first equation? Is that good? The X term, then the Y term. So I just had to switch those too, didn't I? Equals 36. How do I do it for the second equation? I really have two choices, don't I? I could add 10x over here, add 10y over here, and subtract 20 over here. Or I could just take this, flip it over, can't I? Negative 10x minus 10y equals 20. Does that make sense? Because if 20 equals that, doesn't it make sense that that equals 20? Okay. Now, I need to make one of my variables go away. I need to eliminate one of my variables. So I need them to be the same number. What number would this have to be if I want to make it the same? 110. Right? Well, that's a big number, isn't it? Not compared to the distance from here to the sun, but regular numbers that we deal with all the time, right? It's a bigger number. We could cancel y or x. It doesn't make any difference. Okay? What number would the y's have to be if I was going to cancel them out? 40 or 20? Couldn't it be 20? 40, yeah, because I just multiply this one by 10 and multiply this by 4, multiplying by each other, right? But couldn't I do 20 if I multiplied this one by 5 and this one by 2, right? So wait, I can multiply different equations by a different number, and that's okay? Yeah. So what did we say a second ago? We're going to have to multiply the top one by what? 5, and the bottom one by what? Okay, so I see a problem though. In order to eliminate the variables, what did we need? Same signs, but, same number, but opposite signs, right? If I multiply this by 5, that'll give me a negative 20. And if I multiply this by 2, that'll give me a negative 20. So negative 2? Could it have been negative 5? Yeah. But not both negative, right? That would just be silly. So if I multiply the top equation by 5, I get negative 55x minus 20y equals 30, 60, 180. Can you do that one in your head? Can you do 5 times 30 in your head? What's 5 times 30? 150. What's 5 times 6? 30. What's 50 and 30? 180. Earlier, somebody said, oh, I did it because 36 times 10 is 360, and I just need half of that. 180. We're working on our numeracy. We're working on our comfortableness with numbers. Okay? Now let's multiply the second one by negative 2. What do I get? 20y equals, good. Combine them. How do I know I can combine them right now? Same number, opposite signs. right? I couldn't combine them here, could I? I only want to combine them when a variable will eliminate, when a variable will go away. Okay? I know one will go away right here because I have same sign or same number, opposite sign. Okay, so go ahead and combine these. What do we get? Negative 35 equals, yeah, that's 0, right? Equals what? 140. Divide by negative 35. X equals negative 4. So now I'm done? No, oh no. Okay, what do I need now? Why? Because? That was just a little joke. I'm sorry. You said why, so I said because. Because like you're asking why and I okay. Now, so I need y, so how am I going to get y? Substitute it back in where? Wherever, right? So back in this problem? No, that's silly. Which one? First, second? First, okay. Negative 4y minus 11 times negative 4 equals 36. Negative 4y plus 44 equals 36. Next step. Good. $36 minus 44? 8. Oh yeah, that's better. Divide by negative 4. Y equals 2. What's the answer? Negative 4, 2. Are you positive? Check it. So we can be. Okay, let's see. 8 plus 44, excuse me, negative 8 plus 44 equals 36. Negative 8 plus 44 equals 36. Correct, right?